Welcome to today's Explainer. I am absolutely thrilled you're here because we are unpacking something truly monumental today. We hear these heavy-hitting tech buzzwords thrown around constantly, right? Artificial intelligence, quantum computing, humanoid robotics. Honestly, it can feel a little overwhelming. But today, we're going to cut right through all that noise. We're going to demystify these incredible technologies, and more importantly, we're going to explore the fascinating reality of what happens when they all combine into one massive, powerful engine for the future. To kick things off, I want you to hold this single, provocative question in your mind. What exactly happens when artificial intelligence gets a physical body? For decades, intelligence has basically been trapped behind our screens. But right now, we are crossing a major threshold where the digital mind is actually stepping out into the physical world. Let's look at how we're going to break this all down.
Here's our game plan. 1. Demystifying artificial intelligence. 2. The quantum computing leap. 3. AI enters physical reality. And 4. When three technologies converge.
All right, part 1, demystifying artificial intelligence, the digital mind.
A lot of folks tend to think of AI as this invisible, magical cloud just floating out there in the ether. But let me tell you, it is absolutely not magic. It is a massive, highly physical stack of technologies, built layer by layer, kind of like an anatomy chart, where every single layer depends entirely on the one right below it.
Let's actually walk up this stack from the ground level. The foundation, it isn't code, it's raw energy. That massive electrical power fuels specialized GPU chips, which are housed in these vast physical data centers. That infrastructure holds the curated data, and that data is what trains the AI models. Think GPT or Claude. Then, only at the very top of all of this do we get the applications that you and I actually interact with in retail, healthcare, or education. It's a remarkably deep physical foundation.
And this digital brain learns through a continuous loop. It ingests and prepares data, trains on patterns, and then makes real-world predictions. But here is the absolutely crucial step: feedback. The system takes those results, feeds them right back in, and retrains itself. It's not sorcery, it's just relentless mathematical iteration. It turns data into decisions, and it is constantly improving.
Moving right along to part 2, the quantum computing leap, our hyperdrive.
The core difference here is fundamentally how these machines think. Classical computing, like the laptop or phone you're probably using right now, uses sequential bits. It processes zeros or ones just one at a time. But quantum computing uses qubits. Through a wild property called superposition, they can exist in multiple probability states at once. And then, through interference, quantum algorithms actually amplify the right answers and cancel out the wrong ones. It's a totally new paradigm of mathematical processing.
And this translates to some massive, real-world breakthroughs. Because qubits can hold these combined states, we aren't just talking about running a faster spreadsheet. No way. We're talking about simulating complex molecules to accelerate drug discovery, designing entirely new compounds and materials science, and running highly accurate climate models. It literally allows us to solve problems that are fundamentally too complex for classical computers to ever crack.
But, okay, let's do a quick reality check here. While the progress is absolutely accelerating, quantum computing is still largely in the research stage. You aren't going to have a quantum processor in your smartwatch anytime soon. Wide, everyday practical use is still years away. It's essentially the hyperdrive we are currently building in the lab.
Section 3. AI enters physical reality, the physical body.
The robots we're seeing today didn't just magically appear overnight. We are looking at decades of relentless, step-by-step engineering. Back in the 2000s, we had these early prototypes that could barely walk and keep their balance. By the 2010s, research platforms achieved dynamic movement and agility. Think of those wild parkour-doing robots you've seen online. But the 2020s, that changed everything. That is when AI foundation models finally met hardware. AI gave these machines the intelligence to perceive, plan, and adapt. Which brings us right to today, early deployment, where we are literally seeing pilot programs testing humanoids in real functioning industries. However, let's be real. There are significant physical limitations holding widespread adoption back right now. Think about human dexterity for a second. The human hand has an astonishing 27 degrees of freedom. Replicating that kind of delicate touch and manipulation in a robot hand is incredibly difficult. Then there's battery life. Under a typical heavy load, most humanoids can only run for about 2 to 4 hours before they need a charge. Add in the super complex safety protocols of operating heavy machines around people, plus the fact that these units currently cost tens to hundreds of thousands of dollars each, well,
We're definitely making progress, but the physical world is just much harder to master than the digital one.
And finally, Section 4, when three technologies converge.
So here is the ultimate payoff. AI provides the perception and learning today. Quantum computing, as it matures, will provide the simulation and complex calculation power. And robotics, that turns those digital decisions into precise physical action. Just imagine this micro story for a second. A quantum computer models millions of variables to design a perfectly resilient supply chain. Then, the AI uses that model to predict the absolute most efficient daily logistics route. And finally, an autonomous robot physically executes that route, assembling products in a smart factory with literally zero waste. We are going to see this impacting manufacturing, logistics, complex surgery, and even faster, safer disaster response. It's this complete end-to-end loop of intelligence taking physical action.
But amidst all this mind-blowing technological power, there is an overarching, non-negotiable truth we have to remember. Technology works best when humans and machines work together.
Let me be crystal clear about what this does not mean. This is not some overnight human replacement. Jobs will change, sure, but gradually, sector by sector. Our creativity, our empathy, and our judgment remain uniquely human traits that absolutely no AI stack or humanoid robot possesses. Most deployments are still going to rely heavily on human supervision, and transparent, responsible design remains absolutely essential. These tools are being built to enhance us, folks, not to replace us.
Which brings us to a final thought for you to chew on. The next decade will really decide what this convergence truly becomes. The future engine of AI, quantum, and robotics is revving up, and intelligence is officially entering our physical realm.
So I'll leave you with this question.
How will you adapt and elevate your own unique human skills to thrive alongside this incredible new technology? Really think about that. Thank you so much for joining me on this explainer today. Keep learning, keep asking those big questions, and I'll see you next time.